Now we're going to look at analyzing graphs of variations of y equals sine x and y equals cosine x. So we have our two functions. Sine x is this blue, and then cosine x is this orange. And this kind of, I don't know if you call that teal or something to correct me with what that is. That's f of x equals sine of x minus pi. So what we're seeing here is a phase shift. It's been shifted. So it's been shifted back by pi, by pi, excuse me, I should say shifted to the right by pi because it's minus. So notice that it's going up here, and this one's going up here. You just change colors. It's going here, it's going there. So that's a distance of pi. Now, sine is a cyclical function or periodic function, so it repeats itself. So it's hard to see which way is really going if it goes on forever. But we're going with the fact that it would have been here, but it's shifted by pi over to this area. And so this peak here, it's over here now. This bottom is, this bottom is over here now, shifted by pi. Okay. Now, notice this pi occurred within the parentheses before it applies the sign. So that affects the horizontal part. Now, if you have it added outside, it shifts the vertical part. So the midline, instead of being on the x-axis, is up a little further, or could go down. So here's y equals sine x, and here's y equals sine x plus 2. It shifted up by 2. So now that midline is up here at 2. So variations in sine and cosine functions, phase shift and vertical shift, given an equation in the form f of x equals a, which was our amplitude, sine of bx minus c, so b affects the period, minus c plus d. So minus c, that's going to affect the phase shift, and then the d affects the vertical shift. Or f of x equals a cosine of bx minus c plus d. So c over b is your phase shift, and d is the vertical shift. Determine the direction and magnitude of the phase shift for f of x equals sine of x plus pi over 6 minus 2. So our phase shift is going to be, here's our c. Our b is the coefficient for x, so b must be 1. C is pi over 6. So the phase shift is going to be c over b, which is pi over 6 over 1 in this case. So it's just pi over 6. I'd make some more comments about phase shift, but I'm going to reference Star Trek, and I bet no one who watches this video would know what I'm talking about. Okay, determine the direction and magnitude of the vertical shift. So that's going to be this minus 3 on here. So this has a vertical shift of negative 3, or it shifts down 3 units. So how to identify the midline, amplitude, period, and phase shift of the sinusoidal function in the form f of x equals a sine bx minus c plus d. Your amplitude is absolute value of a. Your period is p equals 2 pi over absolute value of b. The phase shift is c over b, and the midline is y equals d. Okay, kind of summarizes what we just saw there. Example 5, it says determine the midline, amplitude, period, and phase shift of the function y equals 3 sine of 2x plus 1. So our midline is going to be d. It's going to be 1. I should say y equals 1. Our amplitude is the absolute value of 3, which is 3. Our period is going to be 2 pi divided by the opposite value of b. So it's going to be 2 pi over 2 which is pi. And then our phase shift is going to be, well, I don't see a c. C equals 0. It's c over b. So it's 0 over b, which is 0. So there's no phase shift. Okay. I was going to say science fiction shows, Stargate, Star Trek, a lot of them use the concept of a phase shift, which is, they just like to use math terms that don't really apply. Okay, determining the formula for the cosine function. So normally a cosine would start up here, and now it's starting over here. So I see a shift of, that's 2 pi, this is pi. So I see a phase shift of pi. Okay. What else are we seeing? Oh, the midline is at 0.5 instead of at 0. So D must be 0.5. Let's see here. It starts, I'm looking at a one full cycle going from pi to 3 pi. So the period is 2 pi, so B must be 1. And our amplitude, notice it goes from 0 to 1. Normally go from -1 to 1, so our amplitude is half what it would normally be, so A must be 0.5. Now I'm going to be honest, that you could probably find multiple ways to represent this one, but here's how I'm going to represent this. I see this as y equals 0.5 as our amplitude times, now I'm not going to do that parenthesis yet, cosine of b is 1, so b is 1 times x, so 1 times x minus c. Now notice pi is going to be c over b, and since b is 1, c must be pi, minus pi plus 0.5. So y equals 0.5 cosine of x minus pi plus 0.5. I should probably verify that with the answer key. So, okay, I looked at the answer key, and it's, well, it's wrong because it says b is 0, and b is clearly not 0. It's a coefficient of x, and that's 1. And they say c is 0, but no, they're not taking into consideration the phase shift, and it has 1. So, anyway, this is correct answer. I'm going to stand by that. Okay, unless someone sees a mistake in my work, please post it, as I'm sure you will. Determine the equation for the sinusoidal function. So I'm tempted to go with a sine on this one. And let's put this together. It could go with a sine or a cosine. I guess it's a matter of, let's start putting things together. I guess if we want to do a small shift, we see this peak should have been at 0, so we could look at that shift for our C. So that our phase shift is 1, and that would put us in the cosine function. You could identify it as a sine function. I'm going to go with cosine because it's a smaller shift. And then, let's see, our high is at 1, our low is at -5. So the amplitude is going to be the absolute value of, or sorry, it's 0.5. I'll just do divided by 2. 1 minus -5. So that's going to be 6 over 2, which is 3. So A equals 3. We're going to go with that. And what are we looking at for a period? So going from 1 to 7. So the period is 6. Okay, that means that 2 pi over b equals 6. So 2 pi equals 6b. We'll divide by 6, and b equals pi over 3. So let me see what I have so far. Y equals 3 times cosine of pi over 3x minus, so let's see what our c is going to be. Since the phase shift is 1, so 1 equals c over b, 1 equals c over pi over 3, so c must be pi over 3, minus pi over 3. And then we look at the center line. So we said 1 to negative 5, so I think the center line's at 2, negative 2, isn't it? So that'd be right about here. So our d is a minus 2. So minus 2. So y equals 3. So I guess rewrite the same thing. 3 cosine of pi over 3 times x minus pi over 3 minus 2. Okay, that was kind of fun. This is going to be a long video, and I apologize. But I think, yeah, we'll stop there. The next one we'll do graphing variations.